presentation over. We're doing this via Google Hangouts, so people out in the real world can watch it live. We're also recording the video on a couple of video cameras. We do have a YouTube channel out there where we're throwing these videos, so if you ever want to tell your friends about it and go watch the video, you can do that. The Hangout is an on-air, so that's going to get recorded as well.
Yep.
This isn't the real world?
No. So I'm going to, if everything's up and running, at this point I'm going to turn it over to Ben Rousch. He's going to talk about Raspberry Pi and sensors and Python, and I'm not even sure what all else.
That sounds about right.
I think we're in for a real treat, though. So Ben, go ahead and
All right.
have at it.
Let's try to point at the crowd.
Oh, refreshments. I did forget to mention refreshments. We do have a small set of refreshments here. It's a cooler with some pop and some water in it. And there's some cookies here. The deal is you put $1 in the jar, you can get a can of pop and a cookie, or 2 cookies. And if you want to, even if it's during the meeting, if you can just do it quietly, don't be afraid to get up and grab one. This pop font up here.
Jim?
Membership is not required, but if you do want to come around, it's 35 bucks a year. It helps cover things like the cost of the space and the speaker and the trains, things like that. Like that.
All right, we'll give this a try. I was a little brave today. I decided to present from the Pi itself. I do have a laptop in case it totally fails. We can do pretty much all of it. But I just thought this was cooler. Of course, it won't be as cool on my neck, but it's the kind of thing you forget. Okay, are we recording it? Are we ready?
Yep.
Awesome. Great. I'm Ben Rousch from Grand Rapids, Michigan. I've been using Python for quite a long time, 5 or 6 years. And I started playing with Raspberry Pi about a year or 2 ago. And this is pretty much the culmination of what I've done in that time. Of course, space will work. So this is a Raspberry Pi, in case you can't see up here, if you don't have one in front of you. It's a little tiny computer, Linux computer. This image has all of the parts labeled, but it's difficult to see, difficult to read them here. You've got USB 2 ports, you have HDMI for video, your power is micro USB. The SD card slot up there is where you put your operating system on an SD card, obviously, insert it. You have your GPIO ports in the upper left, and a couple of other older, I guess, analog video and audio, and an Ethernet port on this particular one. So you get quite a bit on this little tiny board, this little computer, and I'm using a lot of it right now. Almost all of those pieces. So I wanted to start by teaching you how to set up your Raspberry Pi from nothing. Basically, you get a new Raspberry Pi. What do you do with this? You go to the Raspberry Pi website, you download the Raspbian image, and you DD that to your SD card. So you write that image format to whatever SD card you happen to have hanging around. There's instructions for doing that on the website.
Can you do it from Windows?
Yes. Yes, you can do that from Windows. You insert the card in, you boot it up, and the login, everyone always has to look up the login because you don't know what it is. but it's Pi and the password's Raspberry. At that point, you do an RPi update, and what this does is updates the firmware on the Raspberry Pi. So there's updates every few months, so you probably have one waiting. When that's done, I think it'll just ask you to reboot, but if it doesn't, reboot it. So step 5, once you get back in, you run sudo apt-get update, because this is a Debian-based distro. The Raspbian is Debian-based. You do the dist upgrade, and then you go into sudo raspi config, and this lets you set up a bunch of Raspberry Pi specific things, such as the camera, a bunch of internationalization options that are sometimes hard to set up if you're not used to it, and then reboot it again, and you're all up to date, you're all good to go. Any questions about that?
Can you do out from a remote terminal like SSH into it?
It does not come with SSH turned on, I believe, so you'll have to install OpenSSH server and then
One of
from
the
that point on.
one of the things the Raspberry config turns on the SSHD.
You can turn it in the config?
Yeah,
Okay.
the first time you actually have to have a composite or you have to have HDMI, run that and then the SSHD. But you do have to figure out what the IP addresses or
Right.
that are.
Yeah, that's always the fun part when you're headless. So you have your Raspberry Pi, and so you want to do some projects with it, right? And this is where a lot of people sort of fall down. They have this Pi, and they think, oh, this is so cool. Look at this little Linux computer. I can do so much with it. What the heck am I going to do with it? So I'm going to walk through basically 2 things today. I'm going to walk through using a camera, a webcam, with your Pi, and using the GPIO ports. So the first thing we'll talk about is the webcam. I have here about a 10-year-old USB webcam. It's working pretty well on here. So to deal with this in Python is my favorite programming language, and a lot of the things you'll see for Raspberry Pi are in Python. It comes pre-installed and ready to go. So SimpleCV is a wrapper for webcam and for machine vision libraries. Complicated stuff like OpenCV and other similar things like that can be difficult to get into. SimpleCV wraps those and makes it easier. It works with a lot of different USB and like laptop built-in webcams. So it's really nice in that regard. Yeah.
You talked about Python, what was the native development? You're doing C++. Where do you develop? Do you develop it in Raspberry Pi compiler, or do you have a place outside like cross-compiler environment?
How do you develop in C++ for Raspberry Pi? I have no idea. I would
You
not
can do
want
either
to do
way.
that.
You could cross compile on a big machine, or you can compile right on the Raspberry Pi.
Yeah, I mean, you have basically all of the Debian tools available to you on the Raspberry Pi. I don't know how much you actually want to compile on the Pi itself, because it's a 700 megahertz processor, so it can
Small
take
things work, the kernel takes hours and hours.
to compile your own kernel.
Well, when you want to change a module, I also have to pull out the instructions for cross-compile, and I had created a PyKernel-matic on GitHub that one of the things it does is pulls the cross-compile and will recompile it on a faster machine.
Yeah, that makes a lot of sense when you do that.
Well, Python is what, version 3 or 2.7?
2.7 and 3.2 are both included on the Raspberry Pi, the Raspbian distro, I should say.
And the
Not on
SimpleCV
the
is going to be compiled?
SimpleCV, I'm using Python 2.7 today. I think it also works with 3.2. Yeah, so it works, SimpleCV works with a lot of USB webcams, which is nice. And also, the code you write works on Linux, Windows, and OS 10. SimpleCV is available for all those. And for more information on SimpleCV after this, you can see this tutorial. That's the easiest way, I think, to get started with it. And it's kind of interesting. I gave this talk a little while ago to my local Python group, and I used the Raspberry Pi camera. They sell a special camera just for the Raspberry Pi. It plugs into one of these ports, and it worked really well. And there is a special Python module just for using that Raspberry Pi camera on the Raspberry Pi. It's really nice. But I had trouble with that camera after I did one of the firmware updates. And so just like 2 days ago, I ended up switching to the generic webcam. So that was interesting. But what I found is, in doing that, I switched to SimpleCV from that specific module, and I'm really impressed with how easy it was to convert all my code over to SimpleCV and make it, cross-platform at the same time. That Raspberry Pi camera only applies to the Raspberry Pi. So I'm kind of happy with that switch. So how do you install SimpleCV? It's really pretty easy. You go to the download site, and they have a link to the SimpleCV version 1.3 Super Pack. And clicking that sends you to SourceForge and to the correct installer for your system. So on Raspberry Pi, it's this deb file. So you just go in, you gpacg-i, install that. It won't work, of course, because there's a bunch of missing dependencies, so you have to get install-f. That fixes all your dependencies and installs them. And then I found a bug in this version, basically it's in all the Debian versions, where there's a PNG missing that it expects to be in a certain place. So in the code I have for this talk, there's a little script you can run that goes out, gets the image, and sticks it in the right place. I'm sure they'll have it fixed soon, so you may not need that. So now we're going to get into some demos and some code. So the first one you may have seen before is a live view. And all these things take a little while to sort of warm up and start. It's just a case of the Raspberry Pi being slow. So what we have here is a live view from the webcam, which is mounted right down here. Somewhere.
James, wave your hands. Hi.
There we go. Up on the screen here, it looks pretty bad, but really it looks nicer. I mean, it's just a case of a projector making it look weird. Washed out, I guess. So we got a live view. It's a good way to start because then you know, hey, my webcam is working. This live view has other utilities. If you get further into SimpleCV, it will track where your mouse is and tell you what color is under that cursor. And what that does, it helps you when you're making more complex programs to sort of figure out what to do. So that's just kind of a cool extra bonus there. Let's look at that code for that. See just how hard it is to set that up. So we're importing from the SimpleCV module we installed earlier, just the camera part of that. You can set your camera settings. It defaults, I think, to 320 by 240 or some tiny little thing. If you're displaying on the Pi, you sort of play with those settings because it can change from webcam to webcam and the size of your monitor and all this stuff. But 640 by 480 is pretty safe. I was able to go up to 1600 by 1200, but doing that would, be bigger than the screen, so it's hard to deal with. So we create an instance of the camera, cam equals camera. It can deal with more than one camera. 0 is the first camera. If you have more than one, then they're 1, 2, 3, and so on. And then the camera size you send into your instance of camera, and you turn on live, and that turns on the live view. So you can see it starts out really simple, just for getting your camera up and running. The next one I'm going to show you. Let's see if we can get this going. I'm starting Chrome here on the Raspberry Pi. Sometimes that can take a minute. Down here I have this is the CPU usage, and this is the RAM. So you can see right now it's pegged, just starting to go here. Okay. So the next one I'm going to do. Where'd I go? I didn't close my terminal, did I? Yes, I did. Oops. So we're going to view a live stream from the webcam onto an MJPEG stream, which you can send over a web. You can view in a web browser.
Are there any video accelerators that you could use on Raspberry Pi, like video encoders and things like that?
There are some available, yeah, but it doesn't really help with this particular thing. Go. Host 80. It's hard to see, but I'm just going to localhost port 80, which should pick up that stream. So now, there we go. We've got the live stream. It's quite a bit slower. You can see we're really taxing the CPU, but usually you would view this from a different computer, not from the Raspberry Pi itself. That's a little bit silly.
Is Chromium part of Raspbian?
It is available in Raspbian, yes. Chromium is.
Chromium.
Chromium is this web browser. It's the open source part of Chrome. So it works really similar to it. I think that's the only thing I need Chromium for. So let's look at the code for setting up that live stream from the camera to the web. So it's on port 8080. You could easily pipe that out through your firewall or whatever to the web itself. So the code's a little more complicated, but really we're importing just the camera and the JPEG streamer, and that's what handles most of the work for you. We've got our camera size settings again, and in this case we have the frame rate, which I'm using 15 frames a second. You can play with that. It depends on your webcam and the Pi speed and that sort of thing. Streaming to localhost, here's the port, and the length. I only stream for 1 minute, then it shuts down. So we again create that same camera instance, and we set up a stream with the JPEG streamer to the host and port we specify, and the ST is the frame rate basically that it's going to do. So it's going to do 1 per 15. So every 15th of a second, it's going to refresh that image.
Is there an option to do sound or audio with it?
Not built into SimpleCV. This is really just image based.
SimpleCV is just one library in
Yes.
the Python script, so you could
Yes.
bring in an audio.
Right. If you wanted, an actual audio and video stream, you wouldn't use SimpleCV. You'd use maybe like FFmpeg streaming or something like that. You'd use something else. This is really for creating programs around images from the camera. I mean, if you're just like streaming video, there's stuff that'll do that for you in one step. I'm sort of laying the foundation for creating your own programs around the image manipulation and that sort of thing. I mean, there's like one-liners that do audio and video streaming. Okay, so now if you look down here, it's kind of interesting. What we're really doing is grabbing one image from the camera, saving that, and then sending it out into the stream. So it's not actually recording a video off that camera. It's taking still images at each frame and sending that out. And that's another case where we're not really streaming the video. We're looking at each image so we can either analyze it or manipulate it, that sort of thing. Let's not do that. Okay, what's next? We got the live view, the live stream. Next we're going to, well, let's just save a photo. Everybody smile. It's going to come up soon. Yeah, whoever's in front of the camera. Who? That could be interesting. See if it actually saves the photo. Yeah, it still saves it. Yeah. There we go. So there's our picture. So how hard is it to just save a photo to use? Not much harder than that live stream. We have a couple modules at the top, OS and time. We're using OS just to make the path correct, so if we go to Windows, it will move nicely. And time, I'm using just to sleep, so you can sort of ignore those. Again, we just have the camera module from SimpleCV, and I have another utility that I'll talk about when I finish with this. We got our camera size again. We just have a file name, which I'm putting it in the pictures folder and naming it stillimage.png. Now, when it saves this, it actually looks at the extension to figure out what kind of file you want to save it as. Now, down here, I had some issues with various webcams where you get into this too quick and it takes a picture and gets out, and the camera hasn't warmed up. The camera's not really ready, so you get a black image. So I wrote this camera is ready function here is really just looking at that image. It looks at the image. Is this a black image? Okay. We're going to try again a second later. So we sleep for a second and go back in and try again. And with different cameras, it can take like 2 seconds. It can take half a second. It really depends on the camera. So I found this to be really handy. But then as far as saving the image, we just go out from the camera, we get an image, and we save it as a file. That's all there is to it. Let's look at that utility function for checking if the camera is ready. We come in, we take the camera instance, we can debug just prints out the values. So if you don't want to see them, which you probably don't when you're actually in your program, you can turn that off. So it gets an image from the camera. It looks at 1 pixel, which is at the width of the image and the height of the image divided by 2. So the center pixel in that image, it gets the RGB value for that pixel. And if it adds them up. So if they come in as zeros, 0, 0, 0, it's a,
Seems like an expensive way to see if the camera's ready, though, in terms of processing.
I couldn't find another way to do it. I mean, it's really not that. You're getting an image.
Yeah, but
I mean, it'd be cheaper if you could not
the camera should tell you that it's ready, or you should be able to ask the camera if it's ready.
You should. I couldn't find anything that does that, though. Doesn't mean it doesn't exist.
Yeah.
So I just add them up. If it's greater than 0, that means, hey, we got a real picture. If it's 0, then we don't have a real picture and it's not ready yet. Okay, next we're going to save a GIF, which is kind of cool. I just figured this one out today. So what we're going to do here is it'll take, I believe, 5 frames, 1 every second, and then it'll put those together into an animated GIF. So it's going right now. Should take about 5 seconds. Although I don't know if I actually tested this on the Pi, so.
Everybody stay perfectly still.
Yeah, for interesting. There we go. Let's see, does this image viewer even support? There we go.
Oh, hey.
There we go.
We're not straight.
Well, that's pretty cool.
So if the video gets really annoying to record, I think this is a really handy way to do some animation with it.
Sure.
Some animated images. Let's take a look at that. So not too much worse than our saving just a photo, because it's built in. We've got our camera, and we have this time an image set. And that's like it says, a set of images. So a series of images are all stored in an array, and then you can do various things with them. Camera size, we've got a ½ second. So when I generate that GIF, I want a ½ second between each frame. 10 seconds long. Got our file name, so as long as it has that .gif extension, it'll save it as a GIF. We've got our good old camera is ready stuff. And we create the image set, and for calculating these frames, so we do the length, which is 10 seconds, and the interval, which is ½ a second, so we get 5 frames, basically, right? We get our image, we append it to that image set, and we sleep for, what is it, ½ a second, 2 seconds, whatever it is. and then we get the next frame, and we append it, and the next frame, we append it. And then when that's all done, when we have all of our images, we just save it with that file name, and you give it the interval between the frames and the GIF. So you can have the interval that you're getting those images. Like I have a second between each image that I'm getting, but when I create that GIF, I have a half a second between each frame. So it's not real time. Those are independent. You can mess with them, do whatever you want with them.
So did that create one file?
Yes.
Okay. And it has several images in the file?
Well, it created an animated GIF. I mean,
Okay.
so
it is-
You know, it's just a series of images that.
It's a series of
Okay.
images with a delay between.
Okay.
Yeah, you could bring that up in, well, probably not in there, but GIMP, you could open that up in GIMP and see the separate.
Yeah, I would not want to use GIMP up here. Well, that actually brings up a point, because one of the original purposes for the Raspberry Pi is education, right? They want the kids to have a computer that they can plug in and use, but it's really pretty painful to get into things like image manipulation and GIMP. Even
But it-
web browsing is pretty tough.
But it was
sometimes.
education more to teach them how to
program
program
it,
it
yeah.
than to
I think
actually
image
use it as
processing
a.
is a fairly advanced topic.
I don't know, creating an image in there, you know, that's not that advanced, so it's, I don't know. Okay, get feelings about that.
Is there any other way that you can do it for, you have the example, security camera motion detection?
Yeah, we're gonna keep building here. So next, we're gonna save a video. Now, this one might get a little sketchy, because I had a little fun with using video on here. The Raspberry Pi camera was really nice for video, the specialty one. You could do 1080p video, like no problem. Now, you couldn't hardly watch it on the Pi, but it would make really nice videos. On here now, we're recording the video. It's recording to an AVI. I'm not actually sure what the codec is inside of it.
Can you use SimpleCV with the Raspberry Pi camera module?
I don't know.
Okay.
I don't know. You could certainly save your images out and then use SimpleCV to load them in and deal with them. You can see the CPU. It's supposed to be a 10-second video, but it's been longer than 10 seconds. You can see the CPU is pegged here.
Camera's still on.
Yep, camera is still on. We're still recording. So I'm never sure how long to wait before giving up on this one. This is one thing that prompted me to get into the animated GIFs, is the video is a little flaky to record.
Worth noting that the Raspberry Pi has hardware accelerated H.264.
Yeah.
You can save it as an H.264.
I just couldn't get that. Okay, I could get it to save as H.264s, but I couldn't seem to get the resulting file to play on anything. So, in theory, that's a great way to go. I don't know how well it actually works in practice with the webcam. With the Raspberry Pi camera, that worked really well. The H.264. All right, we're gonna give up on this one. See if we got anything. We got a video, but play. Anything else? Not really. Oh, there we go. There we go.
Can you look at the tools and see what code?
Look, it's 43 seconds long. It's only supposed to be 10. But it's not really moving.
I say it doesn't seem to be much of a
You
video.
can look at the tools and look at the code and see what it is. The code is
Yep, I grabbed it. Planar 4-2 wide
Frame rate, that's 25 frames per second.
Yeah, that could probably.
That's asking a lot.
Yep. So if you're gonna do a lot of video, make sure you play with it and you understand what it can record. Now, just because this isn't moving, this video might actually be fine when you view it on a different computer. So don't trust what you see in your video review on the Pi set. Because, like I said, the Raspberry Pi camera on there made beautiful videos that you couldn't even watch on here.
That Raspberry Pi you have, that's the Model B, but not the B plus.
Yes,
right?
this is just a model.
The CPU is faster on the new one too, isn't it?
I'm not actually sure. Okay. So that's our video. And we got our video. Okay, on to the next part here. A little more about SimpleCV. You can get a lot of image properties through SimpleCV, so if you want to do special things like change the colors, analyze it, all that stuff in the image, you can get all that through SimpleCV. You can do image manipulation in there. Tons of stuff. It's really powerful. You can even mark up those images, write text on it, draw on it, whatever you want to do. It has feature detection, and this is really why it was built. It wraps that OpenCV library, and you can look at an image and you can find all the edges. You can find the blobs in there of certain colors. You can do all this sort of advanced stuff with it. And depending on what sort of application you're building, that could be very useful to you.
Facial recognition?
Yes. Yes, it'll find faces, yes. It's in
But will
there.
it recognize them?
That's a separate problem. The
One can say that's
SimpleCV
a face.
will find a human face for you. It will not recognize it for you. Let's put it that way.
How do you compare SimpleCV with OpenCV?
Basically, I believe all of OpenCV is available through SimpleCV. If it's not, you can just sort of go behind SimpleCV and use OpenCV. So it has OpenCV plus other things that it wraps. We're not going to do any of that today, unfortunately. So the next part of the talk is GPIO. I have here, you may have noticed, a small breadboard connected to my Raspberry Pi, and it has something plugged into it. Well, first we'll talk about what is GPIO, just in case anyone doesn't know. What did I do? It's going through it automatically.
Yeah, you're heading backwards and it's going forward, huh?
I don't know. It's like I hit a key that makes it automatically advance or something. Or I accidentally clicked on something 45 times. Sorry. That's... Okay. The hazards of presenting from the Pi. So general purpose input-output. Basically, it's a set of pins on the board that you can hook up to different things. You can hook them up to sensors. You can hook them up to other devices, such as Arduinos. You can hook them up to motors and servos. And some of them provide power. And you can use these to do a lot of stuff. On your Raspberry Pi, this is hard to see, but it's in one of the corners. Just looks like that. Looks like a bunch of pins sticking. And it's changed a little between versions. So this is the Raspberry Pi. Oh, that was A, but I guess it's the B. And in the B+, they've actually added a bunch more GPIO pins. So that's one of the nice things on the B+. You can see some of these provide power, 5 volts, 3.3 volts of power. You've got a bunch of ground pins, and you've got a bunch of GPIO pins. So those are what will let you get inputs and outputs. So what I have up here is this black cable is hooked to my GPIO ports on the Pi, and it goes to this thing here, which is called a Pi-T Cobbler. And that's basically just a little board that lets you plug your pins into a breadboard. And usually you'd use a breadboard when you're setting up a circuit, just because it's a lot easier than trying to hook up to individual pins with other pins. So this just makes it really easy to hook up to the breadboard. It mirrors the pins from here onto here and then to each of these spots, and they're labeled so you can see what they are. If you come up and look at it later, you can see that. It makes it much easier to tell what each pin is. And here I have, this is a passive infrared sensor, motion sensor. I think it was like $6 at Radio Shack, not very expensive. But what it does is it looks at the scene, and if it sees any motion, any change, then it says, okay, I saw a change. It sets one pin from low to high. That's all it does. But it has like a 130-degree field of view, so we're gonna get like constant motion here unless everyone's a statue. So to help you work with GPIO, there is a Python module that wraps it and makes it easy. It's called the rpi.gpio Python module. I think it comes pre-installed on the Raspbian distribution, so you don't have to install it. It gives you access to those ports. The best place to start with this is the examples on SourceForge. And it's kind of a strange thing, but you need to use sudo to use it, because I guess to access the hardware at that level, you have to be root, you need root access. So if your thing doesn't work, it yells at you, hey, you probably should use sudo. So we have a couple demos of this. I'm just gonna run the test first. Here, I'll do this quick. Notice I'm not doing sudo here.
What sensors do you have connected right now?
I just have that one passive infrared sensor, the PIR I'm calling it. See, so if you don't use sudo, you get this message.
You don't really want to
Try
change
running as root.
terms on them now.
I'm not that brave. And I'm something like the Raspberry Pi. I don't pay for those, it's root.
What other types of sensors have you used? Pressure, or motors, or?
With the Raspberry Pi, I have used a button. I've used some LEDs. I think a thermal sensor with it. But it'll work with pretty much everything you can find.
Trouble with motors is that you gotta send the PWM waveform, it's very time sensitive.
Yep,
You get users can do it.
We'll get into that a little bit later. So now if I run it, it says, okay, it's high because I saw motion low. Hey, there's motion again. So this one, when it sees motion, I have it sleep for 5 seconds to wait just a little while before it tries again. Look at that. Not too much, not too complicated. So I'm just using the time module here. You import GPIO from that RPi GPIO library. You have to specify which sensors you're using. So I'm using pin 7 on this board. That's one of the GPIO ports, or pins, sorry. You have to set the mode for the board. I'm not too clear on what that is. But then you have to set, for each pin, you have to say whether it's an input or an output. So here I'm saying this is an input, because I'm reading data from that sensor. And you can set the pull-up value on that. And here we're just going to loop, sleep for 0.1 seconds, look at the state. If it's the same state, then don't do anything. If that state changes, right, we're reading the state from the pin here. So if that state changes, then we say, okay, it changed. So real simple loop to read from that infrared device, or that infrared sensor. Next one is so now we're going to use that sensor with the camera. And it won't take long. It waits for motion and takes a picture when there's motion. Since we have a lot of motion here, it won't take very long to find that. Extremely still. Uh-oh, error. Took a long time to tell me that. Here we're going, we're initializing the camera. Yay! I found movement. Took a photo. So it doesn't, again, it's through a loop, so every time it sees motion, it's going to take another picture.
Can't you detect motion just with the camera?
What's that?
Can't you detect motion just by comparing two frames of camera?
Yeah, SimpleCV will let you do motion detection from the camera. It'll compare 2 images for you and you can decide if there's That's part of it's part of OpenCV, so you can access it from SimpleCV. Right, so we took our pictures, we got the motion sensor that triggered the camera. And so now the sort of culmination here, we'll see how this works, is the security cam. So what this does is it's similar to that where it waits for motion. If it sees it, it takes a picture and then it does a 10-second video.
You know, I just sort of,
You are correct. Let's see how this goes. We might have trouble with the video part again. So it took a picture and then it's recording that video. I think it's 10 seconds, it might only be 5.
43 seconds.
Yeah. Yeah, last time it was 43. Although it's interesting, I might have used a different video size because it's not, the CPU isn't pegged this time. So if I used maybe a small enough video, there, yep. So I used a smaller video size on here, so it actually works.
So earlier you're showing that you could have 2 different cameras.
Yep.
And use multiple cameras. Could you use one for just like a basic something, and then if you wanted the high quality, have the other one turn on if they're like pointed in the same direction?
Yeah, yeah, you can use those two independent of each other and do whatever you want in there.
Or use the low quality one to detect the motion and use the high quality one to actually record the video?
Yep, you can do that. I kind of like the infrared sensor for motion, just because at night that works well. But then this does not work through any kind of window, which I found out, it took me a while to figure that out.
Are you gonna have ports with a couple of cameras?
Glasses okay too.
Well, I have a splitter up here, a USB hub, so you can do the same thing. You do start to run into power issues when you have too many USB things plugged in here. Like right now, I'm sort of on the edge of the power that's provided.
So how do you handle the power issues?
If you have a powered hub, that'll help a lot. I don't have a powered hub.
You could run or power the Raspberry Pi off the powered hub.
As long as it provides enough power.
Yeah.
You have to make sure that it provides the, what is it, one,
I think it's
1
like
amp.
850 million, but that's if you're not using it. I'm using, on USB, I have a Wi-Fi adapter, and I have keyboard and the mouse and the camera all hooked up. And I was having some trouble with it, and it's because I was using like an 850 milliamp adapter, so I went and got, I think this one's 1.3, and it just barely powers this stuff. I can't really plug in anything else.
The camera.
I think the laser mouse will too.
Wi-Fi really.
The Wi-Fi, yeah.
Yeah.
So you do have to worry about power when you get a whole bunch of stuff plugged into it. So the code for the little security camera thing there is pretty similar. We've got our camera and our video stream, like recording a video. Did we forget to look at the same video? I think we did, but that's all right. Our GPIO library, or camera settings. Yeah, so I used a smaller camera here. That's why the video saved. This particular camera in Raspberry Pi works at 15 frames per second with a tiny little video. 10 seconds, I'm using that same sensor pin 7 to read from the motion sensor. So here I'm just setting up a file name based on the time. We got the board, we initialize the camera, and we've got a real similar loop to last time where we just sit there and every 0.1 second we see if the state of the sensor changed. If it does, we get that still image. So we go and find the file name with the PNG extension and save that out. And then we start up the video, we get the file name with the AVI extension and create a video stream. I think we skipped this, so I'll go over it a little more. The video stream object is what sets up the video for you, not necessarily streaming. But it works real similar to the images where you give it a file name, and based on that extension, it tries to guess what codec you want to use. You can use like H.264, and sometimes it'll work. AVI seems most reliable in my experiments so far, as for successfully recording the video and playing it back. So then we're doing the same thing here. We set up the frames. In each frame, we get an image. Then we write it to that video stream. And then we wait, and we get the next frame, and we wait 5 seconds and see if there's more motion. Start back at the launcher. Go back to slides here. So, as, I don't know your name, but as you mentioned, motors and that sort of thing are kind of finicky. And the author of the RPI.GPIO module says, if you're after true real-time performance and predictability, buy yourself an Arduino. Because as you can see, it's pretty easy to peg the processor on the Raspberry Pi doing other stuff, rather than, doing what you may want it to do. So I just wanted to talk a little bit about how you can connect an Arduino to your Raspberry Pi, and then the Arduino will handle all of the sort of I/O stuff for you. And it'll handle talking to motors better, it'll handle talking to sensors in a more real-time fashion than you might get from the Raspberry Pi. You can use them together.
I've seen the other option, let's say going level up to, let's say, a BeagleBone, where you can actually connect the motor, and then you can actually get to the kernel of the BeagleBone's Debian OS and
Okay.
do direct communication, so it's more reliable.
Cool. Yeah, there's a lot of competitors now for the Raspberry Pi. And almost everyone I talk to says most of them are better than the Raspberry Pi.
Except for the video's still best than the Raspberry Pi.
The Raspberry Pi video camera is really good. Yeah, so you may want to look around at like BeagleBone Black. There's like a dozen easily that are competitors to it. The Raspberry Pi has the momentum just because it wasn't actually first, but it was the first popular one. I think was it 4 million? Raspberry Pis.
3.8.
4 million.
3.2, 3.3.
3.3 million been sold, so
That's pretty good.
they have a lot of them out there, and they have a large community. So they really have momentum, even though it may not be the best board. So the other thing you can do with Python and Arduino is you can connect it over USB right to your computer using these two libraries. These are more Python libraries that make it easier to use those. So if you want to go beyond what you're doing with Raspberry Pi, this may be the way to go. We're not going to do any of that today, though. I have a couple of slides with more information, links to all the stuff I used today. The Raspberry Pi, the infrared sensor, the Cobbler that hooks up to the breadboard, and the book Getting Started with Sensors, which I really like that book. It's very useful, so whoever wins that is lucky.
Now, you talked about GPIO, right? How do you talk to sensors that have SPI bus or I2C or something like that? Is it better?
Those are available. I have never dealt with them. Yeah.
There's a SPI module, so I've actually connected a CAN, an MCP 2515 on there, and there's a fairly well-supported SPI library, and some peripherals even have modules for it. There's a Python version for both that, and I think there's one for I2C.
Yep. Okay. Yeah, I have
Both buses are on the 2016. They can either be GPIO or I2C or SPI, depending on how you just have to flip a bit.
Nice. So a little more about SimpleCV, the website. This is a book, a very good book on SimpleCV. So if you like to learn from books.
There's also a new one.
For SimpleCV?
It's an OpenCV with backup.
Okay. Yeah, that might be a good one too. I don't know if they'll talk about SimpleCV, but. And then my code is available on GitHub, and the slides are included in this repo. So if you want to go back and review all this, it's just a PDF. So it's in that repo.
Do you have the sources?
Yep, all the source code is on there too, for all the files we use today.
Can you wait there for a second?
Sure. So that finishes my talk. Any more questions? Yes?
I know it's a long drive from Grand Rapids to come out to do this for us. I really appreciate you taking the trip. Thank you.
Yeah.
Yeah.
direction you came from, yeah,
Yeah.
you'd be fine.
Real question though.
Oh, okay.
Where's the best way to find and get yourself a Raspberry Pi with the things that I'm gonna need so that I can start reading some of this?
I like Adafruit for online.
We also have a local place called Micro Center. It's got,
Do you? 14 at Microsoft.
yeah, 14975, it's got a whole bunch of stuff.
Oh,
And
yeah.
they have a whole section.
Yeah, they've got a really good stuff.
All I have is Radio Shack, and they actually have it here.
B
They
plus
actually
is
have a
$30
section.
there, by the way.
It's mostly Arduino,
B plus is $30 at Micro Center.
but really, that's a
Where
good
is it?
price.
Yes.
Where's Microsoft?
I-75
14 and
and,
75.
Southeast corner.
Prepared to wait in long lines.
Yeah, any time of the day is a long day.
And skinny aisles.
I always, get my stuff online and then go the, quick checkout.
Which is still slow, because everyone else does that too.
It's still a lot quicker than waiting in line.
Yeah, true.
Yeah, I don't know any place in Grand Rapids where you can walk in and buy a Raspberry Pi. You can get Arduino stuff, like I say, at Radio Shack, but that's about it that I know.
I've seen people phone and Raspberry Pi and Arduino.
Ours has a section about as big as this podium. And that's all.
Yeah, that's the Rousch Shack.
It's got about 40 of those sections for each little thing you could think of, right?
I got a comment.
Yeah.
My favorite book on Python is Python for Raspberry Pi by Sam's. It's about $30. It's the best Python book I've seen.
Huh.
I'll put a plug in.
Yeah, I haven't heard of that book. That's, how old is that one, do you know?
I just got it a year ago.
Okay. Do you
It's
know, does it teach Python 2 or 3, do you know?
Python 3
Okay.
exclusively, 2013.
Oh, cool, I'll have to look at that one.
So I just sent out a link on the email group indicating that I found a site that does own cloud on a Raspberry Pi.
Yeah. There was a tie-in, yeah.
Only cloud is our next talk.
Yeah, I actually have that podcast saved for my ride home. Linux Action Show covered phone clouding here. Or no, that was Chromebook. Darn.
Well, they did OwnCloud a few months ago.
Yeah, yeah, this one's about a month old.
Okay.
All right, excellent, thank you very much.
Let me do one real quick thing.